Hello guys, today I'm gonna show you how to implement volumetric clouds and integrate it with weather system and day and night cycle. So let's start. And we will begin with the material for our volumetric clouds. Make sure that you use Unreal Engine version 4.26. As you can see, right now I have material master. It's called m_volumetric clouds, and material instance, which inherits from volumetric clouds master material. Now, when I open it, you can see there is a bunch of nodes. Actually, it's not quite my implementation, but I found this solution on one YouTube channel. I'll leave the link in the description to this video. Actually, you don't need to recreate a bicycle, and the way this person creates volumetric clouds is superb. So I just want you to show his solution. I have contacted him and he actually approved my request. As you can see, my layout is a little bit prettier, there is no mess, and I'll make brief breakdown of this material and tell you how it works in details. Then, wait a minute, I'll show you how to integrate it with the weather system we have created earlier, and how to do some customizations so you will achieve great results. First of all, let's talk about clouds. As you can see from the picture, there is a bunch of clouds. Actually, there are three layers: low, middle, and high, and all the clouds are separated by its class, and they actually spawns on different altitudes. We don't need to recreate every cloud, because the implementation will be pretty much tough and the performance costs will grow. To make pretty and very, I think, natural look, you can actually go with some of them. For me, I found that using only stratus clouds with the cumulonimbus and combining the proper behavior with the curves, you can actually achieve multi-layered clouds, and in some cases you can actually simulate the combination of, for instance, cumulus, stratus, or even cirrocumulus and cumulonimbus clouds. The stratus clouds are the lower one. Sometimes you can actually think that there is fog, especially it looks pretty much like fog near the mountains. And this type of cloud produce little rain or sometimes even snow. The cumulonimbus clouds is the biggest one. It actually produces the thunderstorm, as far as I remember. Also, it produces rain, and this type of cloud will actually help us to create the multi-layered type of cloud system. The cirrus clouds and cirrocumulus clouds are the highest one by the altitude, but it depends actually on type of game that you are creating. But if you have heavy cloud with the stratus and cumulonimbus clouds, this type of clouds can actually be, we can actually withdraw them because they won't make much impact. Sometimes you even don't realize that they are there. So let's continue with our master material, and we are done with our theory. Before we start with our master material, you need to enable the Volumetrics plugin. You can find it in the plugins category and search for Volumetrics. When you enable it, it will ask you to restart your editor. So please do this. Next, it's a little bit pity because I can't use the noise node to produce some masks procedurally for our volumetric clouds. It actually doesn't work with the volume type of material domain. So we need some predefined assets. As you can see from the content browser here, I have the Berlin Worley. It's the volume texture, and the cloud mask. It's the simple texture. The Berlin Worley you can find if you press on View Options and select Show Engine Content, also Show Plugin Content. Then you need to scroll down here and find Volumetric Content folder. Then you can just go inside the content, next Volume Textures, and copy-paste the type of noise you actually want. And for different type of clouds, I think you need to create some of them with the Substance Designer, or you can get it free by the link that I leave in the description. It's the person who created it. And let me show you how it looks. It has actually 4 channels. Each channel for each type of clouds. The red one is for cirrus clouds. The green one, actually I think it's cirrocumulus clouds, maybe. The blue one is for cumulonimbus clouds, and the alpha channel, I think it's for cirrostratus, maybe. I don't really remember which type of clouds he uses for all these channels. I only know that I need the green one and the blue one, because this type of shapes we will create are the heaviest. So there are some elements left. We need to create 2 to start the full development of our shader. Let me show you. It's actually the curve and curve atlas. This curve is a simple color curve. Each channel is dedicated to the proper behavior for each type of clouds that we will create. For instance, the red one is for stratus cloud, the green one is for cumulonimbus cloud. And we also need to create, as I said earlier, the curve atlas. When you create it, you need to open it and add our color curve asset we have created earlier, this one, here. And the basic settings are actually good to go along with. When we create our shader, I will explain how changing these curves will actually impact on the visual look of our volumetric clouds. I think that's all for the setup for the shader. So let's go back to our shader. So, first of all, make sure that the material domain for the volumetric clouds is set to the volume. Blend mode is additive, and shading mode is set to unlit. Here you can see that I have two color. Actually, you can use it as the color parameters. You just need to press right mouse button and select Convert to Parameter. Actually, as you can see, we are lerping between the white one and some gray-bluish one. There is new type of node. It's called Cloud Sample Attributes, and we use normalize altitude in layer, so it scales between 0 and 1, so we can have the proper smooth gradient between our white and gray-bluish color. And this node will actually read through the attributes, or actually, yes, the attributes from our volumetric cloud that we have in our scene, this one, and that's the attributes it reads through. Next, we have the node multiply, and we use the same type of attribute and use it as the albedo color. So it not only lerps between colors with the one type of clouds, it actually will use it for multi-layered clouds on different heights. Now, let's start with here. Actually, it's the way how to implement the movement for our clouds. Cloud speed X, cloud speed Y. So our clouds can move in both directions. And the way we use time attribute here, not the panel one and the vector 3 kinds of form, it's because volumetric clouds, as you can see here, need to work with three-dimensional vectors. So it just won't work with spanner. And if you don't like this layout, you can actually go with append vector and create something like this. And apply it here. So the result will be the same. Append node works just it intended to work. The A is our X, B our Y, and when we append here, this will be our Z. Now, here, this type of logic is for our stratus cloud, our lower one. I mean lower by the altitude. We need to divide the world position on the proper value because our cloud is very, very big. It actually covers the full scene. So to have the proper tiling, we need to use high values. The stratus scale is the overall shape. The stratus detail scale is the noise we will apply on the edges of our cloud. Here we have the value 100,000 and here 10,000 units. When we make this kind of operation, we need to multiply it by our some kind of panel behavior, add it and apply to the texture sample. As the resource for our texture, it's our volumetric cloud. Right now it's parent volley, and here I use mask component instead of using actually the channels, because I like to have this type of layout. It's much more easier to read through, but you can actually go just by expanding or maybe extruding the wires from the proper channel. So let's continue, and we'll go with the overall shape. Here I use the red and the blue channel from our noise texture, and multiply it to some sort of noise logic. Actually, I really don't know how to I guess I will try to explain it more consistently. Just don't be too harsh on me, because the way it looks and the way you need to create everything, it's a little bit heavy. So, as I said, we have the multiply node with some kind of noise logic. Let's talk about this. Well, actually, it's not really much the noise. It's our masking type of logic. It actually tells what kind of shape we will have when we apply our operations here with masking from the proper channel from our texture. Let me show you with what. With this kind of texture. For instance, cumulonimbus cloud. So, have the proper tiling applied to our cloud, or actually to the shape of our cloud, which we will have from our texture here, we need to do pretty much the same kind of logic we did here, but because it's the texture 2D asset, we need to use mask and use only two channels. It's UV or X and Y or RG channels from our world position, divided to some kinds of big value, so the tiling will be the proper one. I'm sorry guys for this noise. I'd like to apologize one more time, that was my dry cookie. I hope it won't disturb me anymore. So, let's continue. And, as you can see, we have our panel logic applied to all of our textures. So all our textures are actually moving. And this will create the visualization of cloud changing shape, some kind of fluid. So let's go back to our bigger shape of stratus cloud. We have mask from the red and blue channel. Then they are applied, not applied but multiplied. If you talk about red channel, it's the green channel from our cloud mask here. And if you talk about the blue color, blue channel, it's multiplied by this sort of logic. We add to the blue channel the attribute called cumulonimbus detail to add. It's actually some sort of noise we need to add to have different result in shapes. And we use cheap contrast and the attribute called cumulonimbus detail contrast to have more control over the overall noise shape. Also add attributes and the multiply to have the whole mask together. Now maybe let's go with our stratus noise shape. We have multiply here with the value of 1.05. You can go with any kind of value you want. Just be careful so the results won't be pretty nasty. We have the same setup here. So the tiling will be the proper. And when you change these values, you will actually see the results that changing the bigger or stratus scale will actually define the tiling size of the whole cloud, and this logic will only affect a little details, maybe on the edges of your cloud. Here I have pretty much the same logic that we have here. I'm sorry. This one. As you can see, we have mask on the green channel, and we use it, as you saw earlier, for mixturing with our bigger shape here. So make sure to follow the proper order. Also we have 1 minus and mask on the red channel, and we took the maximum value we have from both of our channels, and chip contrast with the same setup. It's stratus detail contrast. This kind of logic we have here, but now it's for our stratus cloud. Also, as you can see, mask on green channel that is multiplied by the red channel from our bigger cloud. Then add node for stratus detail to add. So we are adding some noise for the big shape of our stratus cloud. We add it to our stratus detail contrast and multiply it with the results of mixturing the green and red channel from our mask here and our noise texture here. So take a closer look one more time. Now, let's go here. We need to saturate everything, so we clamp between 0 and 1, so the result won't pop up in some nasty cases. Then we subtract and multiply the results we have, so we can actually blur between -1 and 1 and have the full cover or the fully uncovered sky with our clouds. Changing the value from 0 to 1 will actually go to -1, so we will have the clear sky, and changing the changing the value to 1 will actually lead to the sky covered with full of clouds. Next, the same type of operation, chip contrast, to actually have control over the overall stratus clouds look. Saturate to clamp it between 0 and 1 and multiply it to actually new kind of logic. We have cloud sample attribute, the nodes we have here, and we use normalized altitude layer. The values we have here. This node is called actually I don't really remember. Yes, it's called curve atlas raw parameter. Curve atlas raw parameter. The parameter name can be changed. As you can see, my is called cloud type by altitude, and here we need to set up our curve atlas and the curve we have from our curve atlas. When you apply the curve atlas, the curve field will be cleared. Each curve atlas stores its own curves, so make sure that your curve atlas has assigned the proper curve as the curve gradient array element here. Now we use red channel. The red channel goes from our atlas, color curve, and its control only our stratus cloud, only this. Now let's head back to these parts of shader and talk about cumulonimbus cloud, the second type of cloud we create. From this texture, cloud mask, as you can see, the blue channel is for cumulonimbus type of shape. We need to mask blue channel, subtract and multiply it, subtract by 0.5, multiply by 2, to have the lerp in between -1 and 1, and the attribute is called cumulonimbus scale. It will actually change the overall size of our cumulonimbus cloud. Then pretty much the same logic. Contrast, it's the shape, some sort of customization. Next we need to saturate to clamp the values between 0 and 1, so everything will work fine and there will not be artifact. Next, we are multiplying it with the result we have from our logic we have created earlier, this one. Here and here. Follow the flow, mask on blue channel, cumulonimbus detail to add with cheap contrast, which we have from the green mask on our stratus detail, the smaller shape on the green channel here. Next, we need to subtract from our cumulonimbus cloud the green channel from our cloud curve atlas. I'm sorry, cloud color curve. It's a little bit evening, it's actually 6 p.m. and I'm a little bit tired, so we are subtracting this curve. Changing the values here will actually lead to different behavior for our cumulonimbus type of cloud. Then saturate, subtract, multiply and add, but now when we learn between -1 and 1, this will actually change the coverage of our cumulonimbus cloud. When we have attribute value 0, it means our cumulonimbus won't show up, and when we have the 1, it will actually cover the full sky with cumulonimbus clouds. Then we use saturate and multiply it by another attribute. It will actually change the density or the transparent attributes of our cumulonimbus cloud. Then when we have cumulonimbus cloud and stratus cloud here, we need to combine them, so we will have the multi-layered system. Actually saturate to have the normalized value between 0 and 1, and one more attribute is called global density that actually will affect on both clouds, both type of clouds, and it will actually go to the multiply node here from our results here and goes to the extinction, and this attribute is needed to have our clouds populated through our sky, and it actually affects on the transparent attributes of our clouds too. So I hope you understand everything. Let me demonstrate it, the whole graph one more time. The tiling for our mask texture that goes for the overall shape of our cloud. Tiling for the shape, the bigger shape of stratus cloud. Tiling for the noise of stratus cloud. Speed, so we can move our cloud in the sky. Volume textures, here and here. Cloud mask here. Next, masking by the proper channels and multiplying it, adding attributes to have more controls over the visual look of our clouds. This one, our cumulonimbus cloud. Next, stratus cloud density or coverage. The same but for cumulonimbus cloud. Then multiplying everything by the altitude. Next, combine everything, global density, and that's actually all for our basic shader setup. Now let's go to the weather system and make it work with it. Now I'll show you quickly the color curve setup for the cloud side by altitude I have, so you can achieve the same results that I have. And actually it's the way I found my clouds to look more realistic than ever. So it's up to you to go with this setup, or you can go with along with your own setup. Let me demonstrate it by each channel separately. Red one is for the stratus cloud, so 0, 0, 0, 15, 1, 0.3, 0. The green one is for cumulonimbus cloud, 0, 0, 0, 3, 0, 25, 0, 7, 0, 15, 0, 8, 0.5. Also make sure that the last point is set up to the constant interpolation. And the blue channel, 0.8, 0, 0.9, 1, 1 and 0. Now let's see what do we have here. In my weather system, I actually need to create some more curves to have the proper behavior, especially when the sun rises or sun going down to the horizon, because we have some fog and scattering and we need more control over the colors we have on our horizon. So for this I have created two color curves. The one is for fog sunny state of weather and one for fog cloudy state of weather. It's actually the gradient, and the reason why I chose color curve instead of vector curve is because I can visualize the color I will have on a particular time of day. The color is clamped between 0 and 1. So from 0 to 1 it's 24 hours. It means that when we have 0.5 it's our 12 o'clock or our noon. So 0.25 it's our 6 o'clock and 0.75 it's our 18 o'clock. So manipulating with the values I told you right now, you can actually see that we have some pretty behavior for our sunrise and our sunset. This type of color curve is for the cloudy state, and this one when we have our rain. So actually, as you can see, the values they have, I mean timestamps, are actually the same, but with different colors. Also, you can see that it's not the linear interpolation, but we have auto tangents, and in some cases we have even flat tangents. Let me tell you about the basic scene setup, so our volumetric cloud will work. As you can see, in the world outliner I have the volumetric cloud actor. You can find it in the place actor category by simply typing the cloud. Then you need to drag and drop volumetric cloud actor to your scene, and we have some attributes to set up. Cloud tracing actually applies to the overall look and the quality of clouds you will have. The higher values is, the higher quality and more performance cost it will be. And some layer customizations. The altitudes at which the cloud layer starts and ends, and the distance at which these clouds will render. So, by changing these attributes, you can achieve different results, from nearly flat clouds to some fluffy ones. So play with these attributes and set up the values you would like. Now let's talk about sky atmosphere. Here I have high fog contribution set to 0.5, so when my sun is rising up or setting down to or from the horizon, I'll see some sorts of fog and scattering distribution at the horizon. The higher value is, the more impact on the overall gradient I will have. So choose wisely the values you need. Also, right now we have pretty much cheap the overall scene skylight recapture, so you can actually select real-time capture here and stop using the cube maps. Also, this means that we need to actually remove any sky capture logic from our weather system. So as you can see, in previous tutorial there was one event set by timer. It was called recapture sky. Let me show you from the difference that I have in my version control graph. Let me see the defaults or event graph here. In early version, it's on your left. I had the recapture sky custom event that was actually recapturing the skylight every 0.2 seconds. This one. Right now, with the real-time capture, I don't need this kind of option, so I can actually remove it. As you can see right now on my right, I don't have any recapture sky logic. So please clear every type of your blueprint. Every place you had this logic, you need to clean. Actually, I think it was for our construction script 2. Yes, we had it on our left, but now we don't have it. Now, let's go to directional light component or actor, our sun, and make some changes here. First of all, right now we have an option called cast shadows on clouds, on atmosphere, and cast cloud shadows. When you check cast cloud shadows, our clouds will apply shadows from them on our ground. Make sure that atmosphere sunlight index for the sun is set to 0, for moon is set to 1, so there won't be any shadows at night seen. It's really not necessary. And changing these attributes will actually lead to some different clouds behavior. The lower values for strengths and surface impact, surface strengths are, the less dark scene we will have. The higher they are, when the cloud covers our sun, the more darker scene we will have. But it will lead to actually more performance cost. And in my opinion, for instance, I'm running my prototype on GTX 1050. For my project, it's a little bit heavy, so I can fake the cloud shadows by using the light function on my directional light. But for some cards, for instance RTX 260 and higher, this won't be any trouble. They won't have any trouble with them, so you can check this attribute. Also, you can go with cast shadows on clouds. For instance, if you have a skyscraper that is actually higher than our stratus clouds, and you have some sort of cinematic scene when you are flying by your skyscraper, so checking this attribute will actually lead to have the shadows from your skyscraper on your clouds. But to make it work, you need to do the following customizations to your shader. So, back to our shader. We need to add volumetric advanced output. It's actually some more controls over our sky, our clouds. You can read through the description by yourself, but if you talk shortly, it actually tells how the light should be distributed in your cloud. For instance, some shape or some area of cloud should be more brighter or darker, depending on the direction of the sun ray applied to the cloud. But make sure that you have connected the results of a roll shader computation clouds here to the conservative density of the volumetric advanced output node. So we actually need it when we have the movable sky, our movable clouds, and the dark areas of our clouds won't be popping up. So this will actually prevent the artifacts from our clouds. You can change any attribute here, but make sure you don't go with higher values, because it's very performance cost. Actually, if you don't have it, you can go along with this setup. You will actually have pretty much decent results, so please choose wisely. And actually, if you read through the description of all of these, not actually this, but these attributes, they work only when you have this node in your shader. When you don't have it, changing values here won't have any impact. And the last attribute we need to change, it's in our high exponential fog. Here you can see that I have directional in scattering color set to the black one, because if we have some color assigned here, the gradient from the sky atmosphere will actually be ruined, and we won't have the physically correct behavior when our sun rises or going down to the horizon. Changing this to black and making some color curves that I have created earlier for our fog and scattering color, this one and this one, will lead to some more pretty results. So make sure to check this color to be black. And for our scattering colors here, I can show you the values I have. So please remember, 0.25, it means 6 o'clock. So the sunrise in the real world, sometimes it's between maybe 4-5 hours to 6 hours. The same goes for the sunset. So 0.75 here, when our sun is going under the horizon, so we need some orange color a little bit earlier to simulate the sunset. The same for the sunrise. The blue one during our day, and for the cloudy state, pretty much the same. But this setup works for me. You can go with the one you like. Now, let me see. Yes, I'll show you some changes I did to achieve the results that you saw from the demo. This. Now, I forgot to tell you about one more curve. It's the vector curve here. It's called cloud opacity. And the red channel is for the stratus cloud. The green channel, or y-axis, is for cumulonimbus cloud. The behavior of these clouds are set to simulate the real-world behavior of these cloud types in real life. So stratus clouds are for some shimmering rain or for some snow types of weather. And cumulonimbus, as I said earlier, is for the thunderstorm, heavy rains, and so on. And as you can see, I have the values between 0 and 24. It means the full day cycle. And the opacity are actually not higher than the 1. As you can see from our blueprint, we will be changing attributes stratus coverage and cumulonimbus coverage that we have created in our shader by the values we are extracting through our curve. This one. The cumulonimbus cloud lasts not very long time, as Wikipedia says. It's much more to 4 hours at all. And stratus clouds can be visible through the whole day. So we have some kind of clouds here. Then comes the rainy type of day. We have heavy gray with black colors sky. Then it ends. The rain ends too, and then we have just some little clouds. And at night, in my case, I don't want any kind of clouds I have, so the overall opacity is set to 0. So please make sure that X or red one is for the stratus cloud, green or white channel is for cumulonimbus cloud. Here and here. I'll talk about it a little bit later. Now, let's talk actually about our fog and scattering color. When you open weather system blueprint, we need to add only this type of logic to our overall logic we have earlier to have our volumetric clouds work proper. Actually, we need to add some more customization setup. As you can see, I have volumetric clouds variable here with variable type volumetric cloud. Instance is editable. And as you can see on the construction script, actually checks whether this component is valid. So it will prevent from the errors when we open our level by the first time. And this instance is editable, so when we go back to our scene and select weather system in our world's outliner, you can see that now, let me see where it is, we need to provide our volumetric cloud here as a reference for the actor, so our weather system blueprint will work correctly. Next, I have created this kind of logic. It's for creating dynamic material instance, and the parent is material instance volumetric clouds, then local cached version, and I use set material, target is volumetric cloud component. We actually have volumetric clouds drag and drop to our scene, then we pull a wire from it, search for volumetric cloud component, and one moment please, set material here. So it will have our material. Let me demonstrate it. Just like this. And only then we use update weather. It's our overall updating behavior logic. Event graph is the same. Nothing changed. Right after set relay scattering, here I have set fog in scattering color option. This. Let me show you how it was in the previous revision. We had set fog in scattering color, but we had day fog color, night fog color, and that's all. Then scattering color we had was not actually the proper one. It was okay for the prototyping purposes, but for some more serious work we need the following layout. So here we use normalized to range our current time from 0 to 24. It actually converts it from 0 to 1 because we use color curves that are from 0 to 1 values overall. Now let me check what has changed. And actually that's all the changes we have for our scattering color. So let's go back to this kind of logic. I have created curve linear color variable. Instance is also editable, so I can choose the proper curves for my level. For the fog sunny color, I set fog sunny color by default here. The same goes for cloudy color curve. Also editable, curve linear color, the default reference. I use getClamped linear color values, so even if we have the curves that goes under value 1 on the y-axis, they will be clamped to 1. So we will not have any pop-up artifacts. And for the sunny color, we get clamp linear color value from our fog sunny color curve. For the cloudy, the same kind of logic. Then, depends on weather type curve we have. It means the curve that defines the behavior of our day, whether it should be sunny or cloudy or mixed type. We are actually lerping between these colors depending on our value we have from weather type curve we have. Make sure that sunny state is set to the A field, cloudy state is set to B field. It's the defaults that we actually that I actually have created in the previous tutorial. So A is always for sunny state, B is always for the cloudy state. Next, set scalar parameter value with the proper name, stratus coverage and cumulonimbus coverage for both of our clouds. Here you can see that I also have one more variable. It's called cloud opacity curve. It's a curve vector with a default value, with default reference cloud opacity. It's this type of curve that I showed you earlier. And we're extracting the X value for stratus coverage, the Y value, Y-axis for the cumulonimbus coverage, and actually changing the overall coverage of our clouds leads to the proper real-world behavior. When the small parts of clouds will appear, then the bigger one will appear too. We don't need to create much more difficult logic. Actually, it will be enough. Change only the overall coverages. But you can actually go with some more heavy logic and set two more attributes, but you will need two more curves. For instance, for stratus detail to add and cumulonimbus detail to add attributes. And next, as you can see, I have one more change. It's for the cloud speed. And as you can see from the logic here, it depends on the day length. For instance, if we have day length set to 30 minutes, clouds will have the proper speed. When it's set to 5 minutes, the speed of the cloud speed will be higher. You can go with this type of logic if you want. For me, it's okay. We can actually achieve the result we have in GTA 5 when we have quick cinematic shortcuts, for instance, for sunsets or sunrises, when this type of day are actually go much more faster than the night or day cycle. So we can see the pretty much fast cloud speed changes. Or we can go with one more curve to actually set much more difficult behavior to the cloud. For instance, if you have some thunderstorm, the cloud speed can change. Right now, this will be for the next tutorial, when I will add some lightning and some thunderstorm effects to the volumetric clouds for the cloudy state of day. So right now this setup will be enough for most users, and please just wait for another episode of your sandbox project. Also, make sure that you have cloud speed X and cloud speed Y attributes created. It's the float variable types. Instances are also editable, so you can change them through the blueprints we have in our world outliner here. And actually, when the speed is higher, it costs more because it's all about ray matching. So it will be computing more pixels over the small period of time. So changing speed to some higher values will can actually lead to some performance drops. So please choose wisely. Actually, that's all for the tutorial. With this kind of logic here and here, and some simple curve arrangements and the shader that you saw from the beginning, you can achieve the real life or near to real life volumetric clouds behavior. Well, as you can see here, I didn't tell you, in my weather type curve, I have the sunny state from 0 to 11 o'clock and from 17 to 24 o'clock, and the period from 12 till 14 is the rain state. So make sure to have the proper synchronized behavior for the clouds, for the cloud color, overall sky color, the rain particles, and so on. So the timelines, the arrangements in your curves are pretty much synchronized too. Here, the curve for the rain is also from 12 till 14, and cloud opacity 12, 13, and so on and so forth. Well, please forgive me about my mistakes and the way I'm right now demonstrating you my tutorial. It's all about the end of the year, the overall mood. It's all about COVID and so on. I also have the apartment renovation. It's pretty much at the end, but I'm a little bit tired of this. So the next episode will be much more better quality. And one more time, if you like what I'm doing, please leave your feedback, subscribe, and see you soon.